I actually started recording this video now. So we'll go to NCC programs. Okay. Okay, just a minute. This is the NCC I'm opening. Okay. Okay, so initially you were supposed to do 4 subjects, isn't it?
Yeah.
Used for computing, computer networks, computer systems, databases. I mean, the 4th one was supposed to be software development techniques, but now since exams will be in September, so you are supposed to do all the 8. So that next year, you just start with level 5. Like that, you won't waste a lot of time. You won't waste a lot of time. You won't waste any time. In fact, your level 4 will be even shorter, isn't it? Okay. So today,
Yeah.
we are going to look at the databases. But first of all, I'm going to open the coursework for the databases. Okay, just a minute. Let me answer this call. Hello. Hello. Okay. So first of all, let me open the assignment. So assignment level 4. Assignment level 4. This is the database. So the introduction. Lulu, can you read out the introduction for this assignment?
The introduction.
Yes.
Okay. This assignment contains 3 parts: design, data, and queries, and an assessment. All parts of the assessment related to the ACE property rental scenario below. I go ahead and read down below.
Yes, go ahead.
AC property rentals, background and requirements. AC property rentals, APR, is growing property rental company that now manages over 200 properties on behalf of owners of the property. To date, the company has used a combination of paper-based files and simple spreadsheet to store details of the properties and the tenants who rent the property. The management of the APR would like you to create a database application that stores and processes the data for some of the function of the company. APR manages the rental process on behalf of the owner for a set fee. The owner may own 1 or more properties. A tenant rents a property for a period of time, which can vary between 1 to 12 months. When a tenant is interested in one of the available properties, they must provide APR with some personal information. Currently, most of this information is recorded on a spreadsheet.
Okay, you have finished?
Yes. Oh, okay.
Where did you end?
Spreadsheet, on a spreadsheet, just after.
Where? Okay, you can continue.
I can't see where I ended. Okay, can keep. Yeah, I sent it. Yeah, just there. If a tenant is successful with their rental request and it is approved and verified, APR will issue a tenancy agreement which contains information about the tenant, property rented, and the duration of the rental and the monthly rental fee that the tenant needs to pay. Each property rentals arranges a direct debit for payment of the monthly rental for the tenant's bank details they provide. Tenant and tenancy record are kept for at least 1 year for the tenants has expired, as APR sometimes receive references requests on the conduct of the tenants and if there was appropriately maintained. Did the tenant pay properly? APR will be allocated from their bank if the tenant's direct debit isn't paid. In this instance, the spreadsheet held by APR is updated to reflect an unpaid direct debit and a member of staff will contact the tenant to arrange immediate payment. When payment is received, the spreadsheet is updated again. Sometimes properties may need some maintenance due to problems such as leak taps, fault locks, issue with the heating system. When a problem or fault arises with the property, the tenant will contact the APR and the report. You can scroll down and report the issue to a member of staff. The tenant's name is recorded on a fault report. Depending on the nature and the agency of the reported fault, the members of staff at APR who takes the call from the tenant will assign the reported fault with one of the four categories that the agency of the fault or repair. The fault type recorded will normally identify how urgent the fault reported, e.g. a burst pipe or broken front door will be very urgent and would require, can scroll down, and would require a response within 4 hours. The member of staff logs the relevant information on maintenance request cards and will contact one of the specialist maintenance companies that APRA work with, ensuring that the maintenance company has responded to the fault within the allocated timescale that is identified by the category assigned to the fault. The maintenance manager at APR receives a monthly report categorized by fault types so they can easily see the types of fault that are reported frequently.
Okay, so what you've seen there, these are the four categories. In fact, this scenario I've read, it's for more like a estate company, right? They've got houses and people or companies, they are renting from them. So now the challenges that they are having, they don't have a database. They don't have a database. So you may have some faults with the houses, they need to be maintained. So such needs to be reported, isn't it? So if there's a database, it will be very easy. So this database, when it is being designed, It will be going to look at these four categories, which are categorized in priority A. It needs 4 hours, e.g. burst water pipes and broken front doors. So this is more urgent. If you are renting the house and the house, it has got broken pipes or broken doors, the front doors, not the flash doors inside. Definitely you need that's an urgent. It needs to be handled as soon as possible, isn't it?
Yeah.
So you have to report to the landlord that I've got a broken pipe, water pipes, maybe the doors and so on. Okay. So these, when they are reported to this estate agent, it's not them coming to repair these pipes or broken doors. No, they have contracted a company that will be coming to do this maintenance, isn't it? Okay. So this company, it's the one now putting things in category, those with the agents, those with the lowest priority, just like that. So they have categorized water pipes as the first agent issue. Then the second priority is broken window and no water. At least you can still sleep if the window is broken or if there is no water, isn't it? 1 or 2 days no water. As long as you have water reservoir, you can use those. So those become the second agents. It can be more urgent than a broken pipe, isn't it? Or you don't have actually the door. Then the third one, priority C, is this is responded in 3 days. The first priority can be this. When you report it, the response comes after 4 hours. Let's hope you understand. Comes after 4 hours. Then this broken window, the response comes within a day. So it's 1 day, 24 hours. Then broken internal doors, minor electrical fault. This one can be handled within 3 days, isn't it? So meaning it's not very urgent that let's say the door for the bathroom is broken or the door for the bedroom is broken. Do you think that is very, very urgent?
Yeah.
In fact, there are some houses which are the door for the bathroom which has never even been locked, or the door for the bedroom, the keys are lost. But people are living and staying. It's not very important. Then priority D, this can be responded within 7 days upon reporting, like plastering, decorating, same as painting, isn't it? It's not that important. It's not that important. So when the fault is rectified, the maintenance company contacts APR to let them know what has been done to rectify the issue and to let them know if further repairs are required. The information is updated on the maintenance request card. The maintenance company will then send a request for payment to APR for the works completed. That part of the process is dealt with by a different system that does not form part of the database you are designing. Okay, so there are several issues with the current system. Remember, I said the current system is not a database. It's almost manual. Okay, just a spreadsheet that you record in Excel. So the spreadsheet of the spreadsheets of missed payment isn't always updated, and tenants may go months in areas before it's dealt with. When faults are reported and assigned a category, it isn't always dealt with within allocated time. Contractors do not always contact APR with updates of the faults reported. It isn't easy to obtain up-to-date reports of which properties are empty or when tenants' agreements are due to expire. The database that you are required to develop needs to be efficient and provide APR with immediate, up-to-date information and reports to enable them to offer a better service and to these to chase any issue that exists. So samples of information shared can be followed. So these are the tables that you have seen there. These are the tables. So these are the tables that are going to be used to create a database. But since you have never learned database before, you may not understand what these tables are, isn't it? So I want us to go we are going to the topic one, meaning learning outcome number one. We start learning the databases from there as we are doing the coursework as well. Remember, these are the courseworks which are supposed to be submitted in September. So you need to understand it. And the reason why I've said we have this class, I want you to know how to use Zoom because it's not every time that you are going to be in school. Sometimes I just say, okay, wherever you are, let's connect and do this. I called you because you have seen that you got a challenge. Okay, so let me open. Okay, so I'm going to open the database. I'm going to open the database. Topic one. Okay, so topic one for database, it's introduction to the module and the database fundamentals. The topics will cover an outline of the modules, some introductory topics like what are the databases, examples of databases in use, then data and information. So by the end of this topic, you'll be able to give a definition of what database is, what a database is, give examples of databases in use, distinguish between data and information. So the list of topics, these are the topics we have this is the syllabus, your syllabus, database. The first topic is introduction to the module and database fundamentals. The second topic is database and database management system, which is the DBMS. DBMS is a software that is used. DBMS is a software that is used to design databases. We'll look at the examples of those DBMS. One of them, you know them. You've heard of Microsoft Access, isn't it? It's one of the DBMS. So we'll look at the entity relationship modeling. There's entity relationship modeling 1 and entity relationship modeling 2. We'll look at the relational model 1 and the relational model 2. We'll look at the SQL. SQL stands for structured query language. Structured query language 1 and structured query language 2. Structured query language 1 and structured query language 2. Then database design, supporting transactions in learning outcome number 10, database implementation, learning outcome 11, then summary is just the overview of the database course. Okay, this assessment, it's a 75% exam, assignment also 25%. For exam, carry more marks than the assignment. So let's look at the importance of the database. Relatively new, beginning properly in 1970s. Although it started in 1970s, you know that some organizations, they are doing manual systems. Huh? They are still doing manual systems whereby they just have files, putting things in the files. The systems are not yet introduced, although it started way back in 1970s. So one of the most important components of information technology, one of the most important component of information technology, just a minute. one of the most important components of technology databases. One of the most important components of information technology, databases are everywhere. What it means by everywhere, you find them phones, all the organizations, hospitals, schools, anywhere you may think of, databases are there. Okay. Okay, so what databases hold? You have to know what databases hold about you, meaning that things that can be kept about you. Let's say at school, what databases hold about you? It holds your name, okay? It holds your student number. It holds the courses that you are doing. It holds the contact addresses, including the phone numbers. And it holds other things like status, whatever. Even at workplaces, databases hold certain information. Hospitals, databases hold certain informations. Phones, everywhere. So at least you have information that you have things that the databases should keep about you, isn't it? Hmm? So what databases have you interacted with? I know you have interacted with a lot of databases without even knowing. You have interacted with a lot of databases. Phone is one of the example of a database, the phone book. So we'll take a few minutes to think about this and write down your answers. Anyway, no time for that. So examples of use, we have databases in supermarket. We have databases in supermarket. Then supermarket checkout. You have databases in like credit cards in banks. You have databases in booking holidays. You have databases in libraries, in insurance, in like passport offices, internet, as well as studying, isn't it?
Yeah.
Okay. A minute. This is the examples of the database for health insurance. This is just the architecture of health insurance database or any other database apart from the health insurance. The architecture is the same. So we have this, what looks like a container. That's the database, then types of insurance required, then the personal data. So we'll look at this. We'll look at this later. We'll look at that later. In health insurance, to match a person to the right insurance policy, collect the relevant data about the person, store this data somewhere, match the data to data about types of insurance. If searching from more than one company, then this might be on a multiple databases. Matching people to insurance might use an expert system. So we found something where one of the objectives said that you have to know what is a database. What is a database? Before you read, that definition, what do you think a database is?
Something that stores information, holds and stores information.
Okay, yeah. So a database is a computerized record-keeping systems. This definition is just a general definition for someone to answer it, but for people like you in this field, you have to answer it in more technical way. Okay, so record-keeping system, we have a file system in computer, that's record keeping. Word documents, that's record keeping. Excel, Access, but are these databases? No, they are actually record keeping. They are actually record keeping, they are not data.
Record keeping, yeah.
So database functions, database should be able to store. When we talk about a database is something that should be able to store, manipulate, as well as retrieve information, store information, manipulate information, and retrieve information. So databases range in sizes. There is a single user database on a PC, a small office database with everyone doing the same sort of tasks, medium-sized database system with core data, but people doing different tasks. Corporate databases spread over many sites, very large databases and data warehouse. Then database too, they can be very large. Like they have given the example for the Walmart data warehouse was as of 2004 about 500 terabytes in size. This is 2004. Then today, 2020, I'm sure it's about it's a very big uh, in terms of storage size. So to put this into perspective, 1 terabyte, if it was just holding next, be able to hold over 200 million pages of texts. But databases aren't like a bucket, although they are going to show like a bucket. Database systems are not just a mass of data. It isn't just about what they can hold. They can organize or they are organized. So we need more precise definition of the database. So no wonder they have defined the database as an organized collection of logically related files. Organized, logically related of data, collection of logically related data. So what does this mean? Organized, logically related. Data is structured so as to be easily stored, manipulated, and retrieved from the users. It is not good just having some data if we don't know how to get it in order to look at it and use it. Then related, pieces of data do not exist in isolation. For instance, if you are designing a database, there is no way you can get a database, let's say student, patient, employee. Do you think those are related?
No.
They are not related. If you are developing a database for a patient system, let the records relate to themselves. You can have a patient database, a patient table, doctor table, nurse table, illnesses, admission clerk. It's like that. It is making sense, isn't it? Then for school, you can have student, you can have course, you can have lecturer, you can have the courses they are doing, you can have the librarian. It's making sense. Such things are found in schools, isn't it? Employees, just like that. So if you mix those, meaning that these are not related. By the way, there are types of databases. There are types of databases, and as we are dealing with a relational database, there are types of databases, but the type of database that we are working with is a relational database, meaning that at the end of the day, these tables should be related. That's where the word relational is going. Things should be related, tables should be related. So, for example, in a salesperson database, it's a natural for the customer's name and the customer's address to be stored together, right? Because you find customer's name and the address, oh, they belong to the customer, isn't it? So they have to be stored together. Then they are related together with other data about the customer. They are part of the meaning set. Student activity, what is data? Data is something that is not yet processed, isn't it? It's raw. Data is raw. So what qualities about you might be of interest to college or university? Social networking site, one of them. Then types of data, traditional text such as names, the data type address, numbers such as how many children, dates such as date of birth. Types of data, data types, we have image, sound, videos, and scan of documents. Look at this table. Is this table making sense? Just say yes or no if it's making sense.
No.
Why is it not making sense?
Because according to the date of birth, I don't think it's put according the way it's supposed to be.
According to what?
Because I'm seeing the date of birth and the names, they're not put according to the way it's supposed to be, like alphabetically and stuff.
Okay, at least you even know that that's date of birth, that's what and what, but it's not organized. Because if you just put 19018, what is that? Isn't it? What is that?
Yes.
When you look at this table, field names are nicely arranged. The names, there's a field name called student name. When you look at the other side, there's just Baker Kenneth. We don't know if it's a name for what, student, employee, or what, isn't it? Huh? Yes, but when you look at that table, it is well arranged. Student name, the names of the students are within that same field. Student IDs are within that same field. Date of birth are within that field. This table, it was just what it's like, what you are given is just data. Okay? It's not making much sense, not until it is processed. So that table there, it is now processed. Student name as a field name, it's there. Student ID, it's there. Date of birth, it's there. Okay. So information is important economically, politically, personally. Databases are the key to information. If you have a database, then you can have the information. If you have databases, you can have the information. Then this is now a recap of what we have done. We gave a definition of what databases is, give examples of databases in use, distinguish between data and information. Do you have any question? Any question?
No.
Okay, so let's go to topic 2. Let's go to topic 2. So topic 2 is, okay, let me stop recording, then we record topic 2 separately also, right? Okay.